Nay, greetings fellow cosmic voyagers. Neil deGrasse Tyson here. Look up at the night sky. For millennia, we've gazed at those points of light with wonder and curiosity. For most of human history, space was a dream, myth, legend, unreachable. But now, science fiction is becoming science fact. The cosmos is opening up, not just for astronauts but for all of us. We stand at the edge of a new space age defined by exploration, habitation, and commerce. Commercial flights to orbit, lunar bases, and cities on Mars are moving from concept to reality. The engines are being built, the missions are being planned, the journey to the stars is accelerating. In this series, we'll explore 17 groundbreaking projects paving our path to the cosmos. From hypersonic space planes to luxury stratospheric balloons, these ventures are turning dreams into destinations. Buckle up, the countdown to our future among the stars has already begun. Let's start with access, the foundation of the new space age. Space was once an exclusive club, but commercial flights to orbit are now a reality. Companies are selling tickets for sustained orbital stays, not just suborbital hops. This shift means scientists, artists, entrepreneurs, and tourists can all experience Earth from above. Reusable rockets pioneered by SpaceX have slashed costs and changed the economics of space travel. The launch pad is now a gateway, not a barrier. Affordable, reliable access to orbit is the critical first step for everything else: lunar bases, Mars missions, and more. A robust commercial spaceflight industry is forming, building a sustainable human presence beyond Earth. It all starts with the revolutionary act of selling a ticket to the stars. To see the future, sometimes you look to the past, like the XB-70 Valkyrie. This Cold War bomber, capable of Mach 3 flight, pushed aerospace engineering to its limits. Its innovations in high-speed aerodynamics and materials science are inspiring today's reusable spaceplane designs. The Valkyrie's legacy lives on, guiding engineers tackling hypersonic flight in extreme temperatures. In aerospace, no good idea ever truly dies. Europe's answer to reusable space access is the ESA's Space Rider. This uncrewed, autonomous space laboratory launches atop a Vega C rocket, spends weeks in orbit, then lands gently on a runway. Its plug-and-play payload bay supports research from pharmaceuticals to Earth observation. Space Rider returns experiments safely to Earth, ready for reuse. It's a game-changer for European science and industry, providing sovereign, affordable access to space, the quiet backbone of a bustling orbital economy. Virgin Galactic has made space tourism a reality. Their suborbital flights offer passengers minutes of weightlessness and a view of Earth's curvature. Over 100 people, including celebrities, have already flown, making space accessible and aspirational. Virgin Galactic has built a market and inspired a new generation to dream of space. The grand opening of space for the paying public has begun. The holy grail of rocketry is the single-stage to orbit, SSTO, vehicle. The ReNova SSTO concept from Germany's DLR aims to make this a reality. Its advanced dual-bell nozzle engine adapts for efficiency in both atmosphere and vacuum. If successful, ReNova could cut launch costs by 90%, making space access routine. SSTO would revolutionize how we launch satellites, build stations, and supply the Moon or Mars. Still in testing, ReNova represents a potential breakthrough. It could unchain our ambitions and open the floodgates to the cosmos. The future of space travel may hinge on innovations like this. Polaris Dawn is pushing the boundaries of private spaceflight. This SpaceX Dragon mission will attempt the first commercial spacewalk, testing new EVA suits for future exploration. It's a leap from tourism to true space operations, repairing satellites, assembling stations, and more. Polaris Dawn proves private companies can handle complex, dangerous missions. The private sector is ready to work, build, and pioneer in space. Not all cosmic journeys require rockets. Zephalto offers a serene ascent to the stratosphere via luxury balloon, blending haute cuisine with breathtaking views. Guests rise to 25 kilometers above 98% of the atmosphere for hours of panoramic wonder. The Celeste capsule provides comfort, fine dining, and massive windows for contemplation. Zephalto's approach diversifies space experiences: science, art, and emotion all in one. Balloon technology opens the sky to new kinds of travelers. Sometimes the poetry of space is written with champagne and a view. NASA's X-59 Quest is reviving supersonic flight. Its unique design tames the sonic boom, turning it into a quiet thump. Test flights over U.S. communities will gather data to overturn bans on supersonic travel over land. If successful, high-speed air travel could connect continents in hours. The X-59 could unlock a new era of global mobility. aerodynamics meets artistry in the quest for quiet speed. NASA's vision is a habitable solar system-sustained human presence beyond Earth. The Artemis program aims for a permanent lunar outpost and a stepping stone to Mars. The moon will teach us to live off-world, using local resources for air, water, and fuel. Mars sample return missions will inform us about the red planet's environment and potential for life. Each mission builds toward a multi-planetary future. It's a deliberate, awe-inspiring plan to ensure humanity's survival and fulfill our drive to explore. The next giant leap is already underway. Building habitats on the moon or Mars is tough. Launching everything from Earth is costly. The Atmos Phoenix capsule uses 3D printing and molten silicate electrolysis to turn lunar regolith into metal and oxygen. This process enables on-site construction and breathable air, all from local materials. Atmos has already printed a prototype capsule from regolith simulants. Imagine robotic factories building habitats before humans arrive. In-situ resource utilization is the key to sustainable settlement on other worlds. France's Dassault Aviation is reimagining reusable launch vehicles. Their two-stage system uses a hypersonic air-breathing aircraft as the first stage, launching horizontally from a runway. This approach reduces propellant needs and allows flexible launches from various locations. The air-breathing stage returns for reuse like an airliner. It's a sophisticated, elegant path to affordable space access. Space Perspective's Spaceship Neptune prepares for Mars by training underwater. Neutral buoyancy labs simulate weightlessness and partial gravity, letting crews practice spacewalks and equipment handling. Underwater testing refines designs and builds astronaut muscle memory. It's a low-cost, effective way to prepare for missions where failure isn't an option. Spaceship Neptune's balloon flights and underwater training both pave the way for future exploration. The Rockwell C-1057 is a legendary rumored military spaceplane, possibly a single stage-to-orbit vehicle. Designed for rapid response, it could launch from a hangar within hours, giving the military unmatched orbital access. While unconfirmed, the logic is clear: space dominance requires speed and flexibility. Technologies from these secret programs often trickle down to civilian use. The shadowy space race shapes the future for everyone. Elon Musk's Starship aims to build a city on Mars, a multi-generational project for 1 million people. Starship is fully reusable, designed for mass production and cost-effectiveness. Fleets of Starships will launch colonists and supplies, using local Martian resources for fuel and air. The challenges are immense, but progress is real. Prototypes have flown, landed, and exploded in rapid succession. Starship is forcing us to solve new problems and rethink what's possible. Whether or not it meets its timeline, it's changing our vision of humanity's future. The dream is not just to visit other worlds, but to live on them. SpinLaunch asks, can we reach space without rockets? Their Kinetic launch system uses a giant centrifuge to fling payloads skyward at 5,000 miles per hour. Only after reaching the upper atmosphere does a small rocket ignite for orbit. This method could slash costs and environmental impact for small satellite launches. SpinLaunch has already proven the physics with successful test launches. Sometimes the most futuristic ideas are rooted in the oldest principles of physics. The X-37B is a real mysterious U.S. Space Force spaceplane. It launches vertically, lands like an airplane, and can stay in orbit for years. Its missions are secret, but it tests reusable tech and conducts experiments. The X-37B's payload bay and maneuverability make it a strategic asset. It's a silent, persistent presence in orbit, military space operations at the cutting edge. The cosmos is now a strategic high ground. NASA's Orion spacecraft is the backbone of the Artemis program. Designed for deep space, Orion can take astronauts to lunar orbit and back, with robust safety systems. The European service module provides propulsion, power, and life support. Orion's uncrewed Artemis 1 mission proved its capabilities. Artemis II will carry humans around the moon. This is the final rehearsal before humanity's return to the lunar surface. Orion links Apollo's legacy to our future as a spacefaring species. 17 windows into our rapidly approaching future. From luxury balloons to kinetic launchers and Martian cities, humanity is breaking its terrestrial bonds. This is more than technology, it's a shift in perspective. We're building the tools to live, work, and create economies beyond Earth. The journey will be challenging, but our drive to explore is unstoppable. The ocean is now space, and new worlds await among the stars. The future is something we build, together, higher than ever before. Thank you for joining this cosmic voyage. Stay curious.